Hello everyone, and welcome to today's webinar titled Data Center of Tomorrow, Defined and Driven by Software. The SIA is delighted to partner with Cloud Now to bring you two great speakers today. In SEMA, the Jathani, Director of Product Management from Stratus, and Vanessa Alvarez, Cloud Thought Leader and Director of Product Marketing at GridStore. Before we turn it over to these ladies, I just want to give a couple of housekeeping reminders. First, all phone lines are set on mute, but we do want to take your questions. So if you have any questions at any time throughout the webinar, please use the chat box to the left of your screen. We will do our best to make sure we get through any questions that you ask throughout the course of the presentation. For those of you not familiar with SIA, we are a global trade association representing software and digital content industries, and just like the Cloud Now organization, bring together the leading technology companies to collaborate, network, and ultimately drive our industry forward. One thing I just want to highlight coming up from the SIA that some of you might be interested in is our flagship conference, All About the Cloud, coming up May 7th through 9th in San Francisco. This conference gathers ISVs from around the globe to discuss and debate all things cloud. It's a great place to meet potential partners and customers. If you have any questions or want details, please feel free to contact me. My email address is there on the screen. Okay, and as I mentioned earlier, we're delighted to partner with Cloud Now on this webinar series that we've been working on them with for a few months now. Cloud Now is an organization that the SIA is happy to be aligned with, and I'm happy to introduce the founder of Cloud Now, Jocelyn Graham, who will introduce today's webinar and our speakers. Jocelyn?
Thank you so much. So thank you to SIA, Rihanna, Katie, their team, for all the partnership and collaboration that it takes in delivering this webinar, bringing together these thought leaders, and producing this content. And for those of you who are getting familiar with Cloud Now, we are a nonprofit consortium of the leading women in cloud computing. Our mission is to promote women in tech, but our membership is open to both men and women. All that's required is a passion for cloud. So we're delighted to bring you today's webinar, which is the Data Center of Tomorrow, Defined and Driven by Software. Quick overview, the software-defined network introduces a new breed of computer networks that exist only as software that can be controlled independently of physical switches and routers running beneath it. With the network being virtualized, the breakthrough concept here is that it now becomes possible to deliver a data center as a service. I'll introduce the thought leaders that will be providing more information and context of today's session, and then I'll have them share just a bit about themselves. So we first have Vanessa Alvarez. She is a Cloud Thought Leader and Director of Product Marketing at GridStore. Vanessa is also a Cloud Now advisor. She was ranked as a top woman in cloud, recognized as one of the top 50 women in tech for 2011. She's also received acclaim for her research through articles and quotes published in such top-tier journals as CNN Money, Wall Street Journal, Bloomberg, Forbes. And so we welcome Vanessa, and if you could share just a little bit more about yourself.
Thank you, Jocelyn. Yes, I am currently Director of Product Marketing at GridStore. Before this, I spent 9 years in the analyst industry covering various technologies related to the data center, starting off with the network and ultimately working within the storage space. I am a proponent of cloud computing and believe that in cloud and just in today's data center in general, the convergence of service, storage, and networking is becoming a reality. And so I'm delighted to be presenting this topic with SEMA, and I'm looking forward to some questions as well.
Fantastic, and we're so thrilled to have you. And so we also have SEMA Jathani. She is the Director of Product Management at Stratus. She brings 10 years of experience in enterprise software development. Prior to Enstratus, she was a cloud computing strategist at IBM and responsible for competitive product pricing, messaging, and sales strategy for IBM Tivoli Cloud Solutions. She is also a steering committee member of CloudNow. She holds an MBA from Duke University Fuqua's School of Business, an MS in Computer Science from North Carolina, and a BE in Computer Engineering from the University of Mumbai. She's also distinct in being the only woman in her class at Duke to become a Fuqua Scholar. You can find her blogging at cloudecosystem.com, which is a UBM Tech website. Seema, why don't you share just a little bit more about yourself?
Yes, Jocelyn, thanks for the introduction. So as Jocelyn mentioned, I am the Director of Product Management at a startup called Enstratus. And prior to that, I was working in the cloud computing space at IBM. I have been blessed in meeting some amazing women at CloudNow, and thank you, Jocelyn, for starting the group and giving us the opportunity to do webinars like this. As I was talking to Vanessa, we were discussing how the data center is exciting today, and there's so much happening in this space. So I'm really excited about this webinar and talking more about what is happening in the data center space and how we as businesses can take advantage of the advancements in the technology.
Well, we're so fortunate to have you bring us up to speed on this topic today, Seema. We know that it's breakthrough, that we'll probably start seeing this topic at cloud conferences throughout the U.S. this year. And so we're really on the ground floor talking about it today. I'll turn it over to Vanessa to kick off the content portion of today's session.
Thank you, Jocelyn. Thank you for joining us today. As we mentioned earlier, we have been, both Seema and I have been looking at the data center technologies for quite some time now and really trying to understand how the data center changes, not only with cloud but also with other software technologies that are emerging within the data center space, and really understanding how the data center changes and what needs to change in terms of being able to make this concept and this notion of the software-defined data center a reality today. As you can see on here, this is what the traditional data center, in a very simplistic term and very simplistic graphic, looks like today. As you can see, there are infrastructure silos for the server, networking, and storage environments. And when you look at the data center, the traditional data center of yesterday, what has typically happened in this environment is there are 3 different people managing these hardware platforms. So for the server environment, we have a server administrator who deploys server management tools for physical servers. In the network space, you have a network administrator who is deploying network management tools to cover the network environment. And then in the storage space, you have a storage administrator who is deploying storage management tools to manage a storage environment. The challenge with these environments is that, amongst many other challenges, is that these 3 environments are so interdependent of one another today that to continue to have these infrastructure silos is a detriment to any organization who is looking to gain competitive advantage with their technology platforms. So what happens in a software-defined data center?
So in the software-defined data center, what ends up happening is that hardware resources are abstracted and pooled, and this pool is then managed by an intelligent software that takes input as policies and SLAs and also uses automation to hand out resources to applications. Next slide, Vanessa. And applications are ultimately what end up controlling the data center. The applications have metadata that the infrastructure is able to understand, and it uses this knowledge to orchestrate resources to these various applications. We have then load balancers, securities, and policies that are dynamically layered in to this environment as needed, and automation is used to reduce the manual tasks in the environment. Ultimately, the data center becomes an agile data center that can respond to market needs.
And just to make to point out one thing, if you notice in the first slide when we discuss infrastructure silos, there are no applications there because in a traditional data center, most server networking and storage administrators really only focused on the hardware environment or their infrastructure environment, didn't really make the connection to applications. And applications, for the most part, had their own set of administrators. And so what typically happened in a traditional data center environment was the whole finger pointing problem, which is, once an application went down, it was a matter of who was to blame. Application teams blamed the network blamed servers blamed storage, and it was just a catch-22. In the software-defined data center, as SEMA pointed out in this slide, really the need for software is driven by the requirements of applications today. In most business environments, those applications are changing. There are still a number of legacy applications that enterprises really depend on, but there is also a new breed of applications that are pushing for new requirements that are met with software.
Right, and so next slide we'll talk about why should we really care about software-defined data center. So as Vanessa mentioned, the IT silos, we are able to break them and give control of the infrastructure to a single group. Now that we have a single group, we don't have the blame to pass around, right? So this group is working together to figure out what is the problem if there is an outage. And this group can then, instead of being a reactive service provider, becomes a proactive change agent that can transform this data center into a business service-focused environment and can meet the needs of the business more faster in a more agile fashion. And ultimately, the users have a better experience with the IT department, and they can come to expect the same fast and easy to use service from their IT departments that they have come to like with Amazon AWS. So what are the main three components of the software-defined data center? As we've seen, it's the server, storage, and the network. And so in the next slide, we see how, so we talk about server virtualization and server management, and this is the most mature, well-understood technology in the data center today. We've seen server virtualization in the market for several years now, and penetration is well over 50%. There are well-established players in the market in this space, where VMware, which holds 2/3 of the market share, but we have also other very strong players with Microsoft, which has been gaining market share over the past few years, and then some other smaller players, Citrix and Red Hat. Then apart from server virtualization, we also have very well-established advanced server management tools that are available in the market. And so we won't spend more time talking about this space, but move on to the storage and the networking portion, where there is a lot of advancement and a lot of innovation happening today. So Vanessa will talk next about the storage space.
So kind of to segue into the storage space, because I think server virtualization was sort of one of the first environments where software was actually accepted. If we think about what virtualization is today, it's software. And IT organizations really started to acclimate themselves with the fact that software was going to become a big part of their IT environment. So server virtualization, VMware, Microsoft Citrix, and some of the other virtualization vendors really were the first ones to help IT organizations begin to understand this transition to software and the emergence of a new role for server admins, which is now a virtualization administrator, emerged. And so this new role was really a new way of delivering a server environment in a software-centric way. And so for me, I think server virtualization was really the beginning of the software-defined data center. So what happened when server virtualization was deployed in most enterprises? They experienced a number of challenges, particularly in the storage space as well as the network. Server virtualization really needed a new way of deploying storage, and traditional storage solutions just weren't up to par. So what's wrong with traditional storage today? As you can see, most traditional storage solutions have a single point of failure. They are a physical controller which contains all of the storage capacity and your data. And what typically happens is your data has to go through this one pipe here. And this is where most organizations begin to experience I/O bottleneck. And what typically happens at this point is now you begin to experience a ton of I/O challenges. You begin to experience lag of performance. You just start to hit a lot of issues when you fall into this I/O bottleneck. Server virtualization only doubles that issue, and what's typically known as the I/O blender issue, right, which is you are clogging up all of this data trying to get through one pipe, and server virtualization is really about moving VMs around and having resources on demand, allocated on demand, and so on and so forth. That problem gets even bigger as most organizations begin to evolve their software-defined data center. In traditional storage solutions, the problem begins with the I/O blender, continues as the data moves towards their storage environment nodes, and then what typically happens is the data has to go through a backplane, which is the network, and in most cases requires high performance 10 gig networks. Today, most server environments do have 10 gig networks. However, storage shouldn't be the issue or shouldn't be the driver for those 10 gig networks. And then in this traditional storage architecture, what typically happens is data is processed at the storage node level, usually the most expensive resource in IT infrastructure today. So server virtualization and the move towards a software-defined data center is going to blow this architecture away. This type of architecture is just not conducive to all the moving parts within a software-defined data center, not just server virtualization, but now software-defined networking and, of course, storage. So what is needed? What we have today is known as, in this architecture, software-defined storage. And what this typically means is you are breaking away from this physical controller which contains your capacity and distributing the capacity and distributing the I/O and distributing your performance, and in being able to deliver storage and distribute it to every single device on the network. So you take the software out of the box and distribute it to all the devices on the network that are accessing storage. As you can see in this picture, when you take a look at the virtual storage pool, it'll be able to distribute the necessary storage resources to every single device on the network that is looking for storage. So that way you no longer have to over-provision, you no longer have to overpay for resources that you are not using. Similar to what happened in server virtualization with physical servers, we now start to see in storage. There are many advantages to this. Of course, you no longer need to over-provision for performance, which is what most organizations have done in the past. They would rather pay more to be able to have a guaranteed performance. And in software-defined storage, that's no longer the case. This type of architecture takes the software out of the box and allocates on demand to any device that's accessing storage on the network. So when you take a look at the requirements for a software-defined data center, what is needed for this type of environment? As I mentioned in the previous slide, it's really about distributing that capacity to every single device on the network that is requiring storage capacity, not having it all bottled up in an array or in a box that is not really flexible or agile enough to be able to allocate storage resources on demand to all of the devices or the VMs or whatever it may be that is accessing storage. In the software-defined data center, when you think about all of the different moving parts, it becomes very difficult to be able to be agile and flexible when you look at physical components or intelligence sitting within physical controllers. I believe that automated management is a huge part of the overall software-defined data center storage and in particular in the storage environment. When you're able to allocate resources on demand based on the requirements of a workload, whether it be server virtualization environments, whether it be VDI, or whether it be your SAP environment, your storage intelligence should be able to determine exactly how much capacity it needs and be able to deliver that automatically. And then superior data protection. In yesterday's world, in yesterday's data center, RAID was enough. With today's dynamic workloads, data protection is essential, not only because of disaster recovery scenarios, but simply for manual misconfigurations within data centers. We've seen them happen in the past. I think AWS has had some very high-profile outages where it has been as simple as a network misconfiguration that has brought down availability zones. So data protection is critical. Intel, Microsoft, GridStore, and CleverSafe and others have been pushing erasure coding, which is data protection far superior to that of RAID, which not only protects the storage disks, which is what RAID does, but protects the entire network. It protects every single aspect that hits your storage environment, whether it be network failures, disk failures, bit rot, whatever it may be. Erasure coding is something that looks at this issue very holistically as opposed to just the disk. All of these requirements are critical for an environment that will be constantly moving. When you think about the software-defined data center and the fact that companies will want to be able to move workloads, move data, move entire data centers from one location to another, for whatever the reasons may be, your IT infrastructure needs to be flexible enough to be able to adapt to that. I'll let SEMA kick off the software-defined networking section. And as you'll be able to see, both the storage, server virtualization, and networking environments collide when you think about the network.
So, the same pain points that Vanessa mentioned with storage, the same pain points were felt with networking in the sense that, the intelligence of the network was tied to the physical resources like the routers and the switches, the intelligence lived within these boxes. And it was not very easy for companies or even universities who were researching in the networking space to try out different things or to adjust the network to their needs. They would have to put requirements to vendors, and then the vendors would work on them, and the solutions would show up 2 or 3 years later, which was not fast enough for them to try out these things or to adjust their environments. So the networking industry over the past year has started seeing rapid innovation that they haven't seen for several years and even decades actually. And the concept of software-defined networking came into the picture. And now, since it's been a very recent thing, there have been lots of confusion around what it really is. And there have been groups like Open Network Foundation, IETF, that are trying to define what it really means. But ultimately, what we want from the network is that we should be able to dynamically program all aspects of the network, whether it's the management layer, whether it's the services, whether it's control, transport, everything. We should be able to dynamically program it through software that is separate from these physical boxes that actually forward the packets in the network, so that we are able to adjust the network to our needs more rapidly. And then these devices are programmable through well-defined APIs, so that we can write management software or extend these devices based on what we need at the moment. And then in the next slide, I show that what is happening with software-defined networking, why we really care about is that we transition from the vertically integrated proprietary systems to horizontal systems with open interfaces. So in the next slide, Vanessa, if you can advance it forward, what happens is you have a controller that's defined in the software. It's a software box, which has open interfaces both towards the switches and the routers, and it accesses the switches and the routers through a southbound API, and it can be anything. It could be OpenFlow, for example, which is the most popular southbound API at the moment. And then it exposes a northbound API, which applications can then access to control these controllers. In other words, the applications can drive the controllers and say, this is my need at the moment, and the controllers will drive the switches and the routers to adjust the network based on the needs of the application at the time. And to go into this in a little bit more detail, in the next picture, where you can see that it's not necessary that in the data center you may have a single controller. So for example, if you have a multi-vendor situation in the data center so that you're not tied to a single vendor, or maybe a single vendor does not meet all of your needs, so you have solutions from different vendors in the environment. Now you have the situation that maybe these vendors all talk the same southbound API because you're using merchant silicon, and the merchant silicon exposes an API that all of these controllers understand. But now these controllers, since they are from different vendors and maybe there aren't standards at the moment for the northbound API, they all expose different northbound API. So now you don't want your applications to have to understand so many different APIs. You want to have a data center operating system that talks to all of these controllers and then exposes a common not-bound API to the applications so that the applications can be a little bit more simplified and leave the intelligence of talking to the controllers to the data center operating system. Now, taking this concept a bit further, in the next slide, you see how you can have multiple data centers all separated. There is a controller in each data center that manages the resources, the network resources in that data center. And then you have a global controller that will then talk to all of these different controllers and do global policy and traffic engineering. Of course, you need to have resiliency, so you have master-slave environment with respect to the global controllers as well. So this enables the IT department to introduce new applications in the network more easily and control the merchant silicon through a unified southbound API and have the applications talk to the controllers so that they can drive the controllers to their needs more easily. And so why should we really care about software-defined networking, right? So we've talked about a few of these things. It reduces the complexity of the network. You don't have to manage each of these routers and switches as separate resources. You can manage them as a single pool and have the controller talk to this pool. And because now you're separating out the intelligence from the boxes, it's easy to introduce changes into the software more easily than in hardware. So you can try out new features in the software controller and push those changes out to your network more easily. And then because you're managing these resources as a pool, you can optimize the use of these network resources more easily. And because you're able to use merchant silicon, you can also lower your networking cost that way. Ultimately, with software-defined networking, you can accelerate the time to market for new services and focus on your competitive advantage by focusing on those applications that make sense to the business and have the network react to your needs of the business. Now, all of this has made us realize, okay, software-defined data center is something great. We should definitely introduce this in our environment. But there are definite challenges with a software-defined data center. The deployment of a software-defined data center needs additional investment in terms of the technology that Vanessa and I just talked about. But not only technology, also need the staff and the skills to use these technologies, and all skills need to adapt to the newer models of doing things. It's easy to introduce these technologies in greenfield projects, and where you can try things out and then maybe use the phased approach to expand it to the rest of your data center. And one more thing to note is that these are new concepts, and so technology is right now rapidly evolving. So the challenge is identifying, okay, that which technology is mature and which technology can be used in the data center.
I just would like to add one thing here, kind of piggybacking on that. Technology is at its infancy. It is at its infancy. I think most IT organizations have dipped their toe into server virtualization and kind of gotten the vibe for software in the environment. And if you look at traditional data centers that have been very much all about hardware, this sort of mental shift for a lot of IT organizations is still something that they need to really deal with, and not necessarily from a technology perspective, but more so from a skill set perspective and just from a mental shift, having that mental shift. I think one of the themes that you've heard consistently throughout this presentation is the use of merchant silicon and commodity hardware. Today, it's really not feasible for IT organizations or enterprises in general to continue to make multi-million-dollar investments in hardware that's going to limit their requirements and their competitive advantage. They need an IT infrastructure environment that is flexible and agile enough to move as quickly as they need to move in their competitive industries. And doing so with existing hardware legacy solutions is just not feasible for them. So when you think about the software-defined data center, think about the software being the intelligence in the brains of the data center overall. And at the end of the day, the hardware is really just commodity and will be something that is standardized throughout the data center in order to be able to leverage the cost benefits of commodity hardware. And in summary, I think a lot of these points are things that we've talked about consistently throughout the presentation, but the need for silos to be broken down within the infrastructure environment is critical. There can no longer be independent server, storage, and networking environments. I think this is something that we all know. But as I mentioned earlier, IT organizations really do need to go through that mental shift and understand that these three environments have become very interdependent, and the technology is already there in terms of managing these three environments. However, IT organizations have not been able to grasp the concept of being able to manage these three environments interdependently. So silos need to be broken down. The reality of the commoditization of hardware needs to be, the message needs to be conveyed. As I mentioned, it's just it's not feasible for enterprises today to really continue to make multi-million-dollar investments in hardware that only creates limits in their environments. And then ultimately, the IT organization really needs to take a look at the kind of skill sets that they have in-house today and how they can augment their IT staff and IT organization to have new skill sets that should be able to manage these three environments in a more holistic manner and really not think about it as a server, storage, and networking environment, but think about it as an application environment. As SEMA mentioned earlier, the software-defined data center is truly run by applications and driven by applications, and so the new skill sets needed in this environment will have to be very much application-focused. And then data centers ultimately have to evolve to this flexible and agile way of doing business, as I mentioned. Or enterprises today are in a very competitive market in any vertical that you see today. Let's take retail, for example. They have seen, brick and mortar retail has seen the emergence of Amazon in the past 10 years eat their lunch, and today they are truly trying to become much more competitive and are realizing that technology is a big part of that competitive advantage, and to be able to compete effectively, your data centers really do need to evolve to become much more flexible and agile. With that, we end our presentation. We thank you for attending, and we open it up to questions.
Vanessa, we've got a couple of questions. I'll go ahead and I'll ask the first one. We've talked a lot about the organizational shifts that are necessary. You also touched on the point that for the IT department, they actually got quite used to this idea of virtualization of the servers first, and so then moving over to network and storage in the entire data center is going to take a lot more effort. But for the organizations that are aligned to make that shift or have already made that shift, can you talk about the characteristics of those organizations that are so ready to embrace this early change? What do those early adopters look like?
As I mentioned in the previous slide, and SEMA touched upon it as well in the beginning, the software-defined data center is really driven by the application. So some of the things that I have seen very forward-thinking enterprises start to build within the organizations, and it's still in a very nascent stage, but the concept is really organizing their teams by applications, right, by workloads, by business initiatives, right, something that ties the technology to the business demand that it's meeting. And so that kind of breaks away from the IT silo that we presented in the first slide and really aligns it with the business demand, right? So when you think about the resources that are needed to, let's say, meet a marketing campaign that will be running for the next 3 months, a lot of enterprises are building a team to support that particular initiative from a server, storage, and networking perspective. But not thinking about it that way, really thinking about it, this is the team focused on delivering this marketing campaign, regardless of what it is, whether it's infrastructure, whether it's management, or whether it's the applications needed to support that. And that's one of the things that I have really one of the concepts that I've really liked, because it's really about focusing on the business demand and the business initiative. SEMA, I don't know if you have some other ideas.
Yeah, the other thing that companies are doing is this concept of DevOps. So they have the operations team aligned with the development team that builds these applications. And the operations team is, like Vanessa said, they are not, it's a unified team that focuses on the entire infrastructure versus server, network, or storage. Now, the DevOps concept is that you have the operations and the developers work together so that you can build applications that understand the infrastructure, and infrastructure is supporting of the applications. So some of these early adapters have used this DevOps concept more successfully. And then there's another thing that has come up is this no ops, right? So no ops doesn't really mean that there is no operations, but it's saying that the developers use a platform, and that platform gives them the infrastructure or provides the applications and infrastructure as needed, so that the operations portion is built into the platform. And this ties into the software-defined data center, where how we saw in front of the earlier charts is that there is intelligent software that uses automation to orchestrate resources for the applications. So that's my view of my experience with how some of the early adopters have embraced this concept.
Fantastic content. I don't think there's any other questions that have come in, so we can go ahead and let everybody know about the webinar series that are coming up. There's going to be one switch. We are going to have the April 17th topic on March 20th. So Bernard Golden will be discussing IT as a service provider on March 20th, and our trust assurance and compliance topic will be on April 17th. And Katie and Rihanna, do you have any last wrap-ups?
I just want to thank everybody. This is Rihanna. I just want to thank everybody for your participation today, and certainly the Cloud Now network for bringing this to us. The recording of today's session will be made available for future reference, and we'll make sure that all registered attendees today get a link to that recording once it's posted. So thank you, everyone, and thank you, SEMA and Vanessa.
So thanks for hosting us.
Thank you so much for having us.
Thank you. Everyone have a great day.
Thank you. Please stand by.